Hey geometry students, it's Mrs. Fellon. I am going to go through section 1.3 in your student journals. We're going to talk a little bit about midpoint and some segment bisectors, all kinds of fun things today. All right, I'm on page 14 of your student journals. It looks like this. So grab your student journals and join me. Okay, let's get started. All right, first things first. In your own words, write the meaning of each vocabulary term. We're going to use it in my words. Feel free to add your own as you go through this. So midpoint. To be honest with you, midpoint seems pretty self-explanatory to me. But if I had to make a definition, I would say it's the middle point between two other points. So it's the middle point between two other points. So I'm not going to ask you to define this in specific, memorize a definition. It's more about you understanding what it means. So it's not as imperative that you write down everything that I write down in terms of my definitions, because my definitions are definitions in my words. So if you have a better way of describing what a midpoint is, feel free to write it down or to add it to it. The other thing I'd like to think about is, when you think about a midpoint, if you thought about those, we're going to be doing an investigation and so forth. We're going to kind of come up with a way to calculate a midpoint. And so that might be something I would add to this later on. All right, a segment bisector. So think about what those words mean. Segment, so think about a line segment, and bisector. So a segment bisector means that you have a line segment and it's being bisected. Now the catch here is that it's being bisected by, well, we don't know. Could be being bisected by a line. So we could say a line bisects this segment. And so I would show you that it's being bisected by showing you that the two pieces on either side of that line, that kind of cuts my line segment in half, that they're equal. Okay, so they're congruent, I should say. You could have a line segment, A to B, and it's going to be bisected by a ray. That means this piece and this piece are congruent. You could have a line segment that's being bisected by a point. Again, this piece and this piece are congruent. And we can kind of go on. It could be bisected by lots of different things. A line segment, could be another line segment. Basically what it means is that this line segment is broken into two equal pieces. And so whether a line bisects it, a ray bisects it, a point bisects it, another line segment bisects it, it's being broken into two different congruent pieces. Again, remember the notation. If you look at the notation that I've been using, again, the same kind of little number of dashes on each piece mean that those two pieces are indeed congruent. All right, a midpoint. So remember how we talked about a midpoint is the middle between two other points? If I said, draw a line segment, X, Y, you might do this. And if I said, draw midpoint M in between them, you do this. And then I would mark you off. Why would I be marking you off? Not because I'm super mean. I'm not. But because you didn't do it correctly. Like, how do I know M is in the middle? What if it's like a fraction, a half of a millimeter off? How do you know? Well, to kind of avoid that, I don't necessarily want you to take out your ruler and measure it. I don't really care. What I'm looking for is you to show me that in symbols, how do I know M is the midpoint? The easiest way to do that is to show that these two pieces are indeed congruent. If this piece is congruent to this piece, then M has to be the midpoint. So if I'm asking you to so that would be more or less what I'm asking you to do is to I might say on an assessment of some sort, draw a line segment showing that M is the midpoint. I would expect you to draw in or use these symbols as part of your drawing and demonstration, because then otherwise I wouldn't know that M is the midpoint, for sure. It looks like it is, but in geometry, we can't just go off of looks. It has to be marked or labeled that way. Here's an example of a segment bisector down here. This is where a line bisects it. So you'll notice that it says line CD. It's hard to see the little arrows on the end, but there are some. Is a segment bisector of segment AB. So again, if I asked you to kind of decipher this or to, translate this sentence into what it would actually mean, the symbols into words, this means line CD is a segment bisector of line segment AB. And again, because of notation, because of these symbols being marked, you could say that A to M, line segment A to M is congruent to line segment M to B, or you could even say the distances are equal. A lot of times we use that when we talk about the fact that we know the distance itself, but because we talk about it being a bisector or a midpoint, we can say that they're equal. Okay, midpoint formula. So if you haven't done the investigation for midpoint, the one we did in class, you wanna stop, and we want to do that. You want to do that investigation before you do these notes. Okay, so the midpoint formula. Basically, what a midpoint formula is, and this is looking, pretty crazy over here. All this stuff with the x and the y's and so forth. What we're doing here is, if I ask you to find the midpoint between 2 points, what you're going to be doing is essentially taking an average. So I'm going to write down a couple little things. Maybe you could write them down as well. So I'm going to give you an example. And it might say something like, find the midpoint between, and I'll make some up, 5, -10, and -7, 6. So if you haven't done the investigation, then you haven't necessarily figured out the midpoint formula, which is this formula right here. If you have done the investigation, you already know this formula and why it is what it is. So again, I encourage you, if you haven't done the investigation in your student journals, to go back and do it. We did it in class, but in case you were absent. All right, so anyway, a midpoint formula. If you look at this formula, what it really is, and this is kind of what I talked about in the summary, it is the average of your x values and the average of your y values. So imagine you have 2 points, right? And you know that they're an x distance of here to here, because on your x-axis, that's their distance. Well, the midpoint is in the middle of that. So it's the average of those 2 x coordinates. Well, how do you take an average? You add them up and you divide by 2, right? So you take this coordinate and this coordinate, add them up and divide by 2, and you get the middle. And then you do the exact same thing for y's. The y coordinates, or the y distance from here to here, would be this vertical distance here. Again, the midpoint would be in the middle. Well, how do I figure out the middle between 2 numbers? I add them up and divide by 2. So following this formula, I use MP to show midpoint. I would say x1, x2. I'm going to use, this is my x1, y1. We're going to use this as my x2, y2. Remember, it doesn't really matter as long as you keep the x1 and the 1s together. It doesn't really matter if you use the first point as x1 and y1 or the second point. Anyways, I'm going to do add up your x's. So add up my 2 x's, divide by 2. Add up my 2 y's, divide by 2. So if I do that, I get 5 plus -7, which is -2. And then -10 plus 6 is -4. And I do some fun math here, and I get -1, -2. Remember, what are you finding? You're trying to find a midpoint. A midpoint is a coordinate point, which means it has to have an x value and a y value. So be careful that you're actually finding that, not just like 2 random values here. We're finding a coordinate point. All right, I wanted to give you another example that's a little bit more challenging, and that you'll see this like when you do your practice and so forth. So I'm going to try to squeeze it in here in that substrate paper. Feel free to grab one. The directions, or we'll call the example will say something like, find the end point. So this time we're not finding a midpoint, we're finding an end point, given that 4, -2 is the midpoint, and 12, -10 is one end point. All right, let's think about what I'm giving you here. I'm asking you to find an endpoint, and I'm giving you a midpoint and another endpoint. So how I do this, I don't really do this formula-wise, but you can. The way I think of this is, I think it's more of just like, I don't know, kind of more common sense. I draw a line segment. And I don't actually graph it on a grid because, to be honest with you, it doesn't really matter. So I just draw a line segment anywhere I want. And I'm going to say, okay, find an endpoint. This is the midpoint. So I'm going to put this point here for -2. And then one other endpoint is 12, -10. I always put it at the first one. Again, it doesn't really matter that these are obviously not in a straight line, which is fine. I'm just kind of drawing a line segment and calling the things without actually graphing them on a coordinate grid. What I'm asking you to find here is this. I'm asking you to find that XY. So the way I think of it is, I think of it in terms of like a distance. So think about your X's. So if I know that if this is 12 and the midpoint's at 4, the distance from 12 to 4 is what? Well, if I went from +12 to +4, that means I dropped or subtracted 8. To get to my new X value of this endpoint, it has to be the exact same distance. So if I subtracted 8 to get from this endpoint to this midpoint, I have to subtract 8 to get from this midpoint to this endpoint. So basically what you're saying is you're doing the exact same operation. It's a little algebra here, in order to get from one X to the other X. So if I subtract 8, 4 minus 8, I get -4. And that's your X value of your endpoint. And then you do the exact same thing, but for the Y's. So if I go from -10 to -2, that's actually an increase, so a +8. So if I go to this one and add 8, what's -2 plus 8? Well, -2 plus 8 is 6. So that means my coordinate point, I have an X value of -4 and a Y value of 6. So this is the endpoint I'm solving for. And that's how I do that kind of problem, where you're kind of given the midpoint and not the other endpoint. Now, you could also use an equation, and I'll show you that right here. So if I have this exact same example, and I said this was 12, -10 was an endpoint, and +4 and -2 was the midpoint, and you're asked to find X, Y. Another way of doing this is to kind of do it more algebraically, and you can use the formulas. You can say this X value is equal to, remember, this X value in the formula is equal to the average of the two X values divided by 2. So to come up with that one, you'd have to, let me rephrase that. So in this example here, this equals my midpoint, right? So if I add up my two X values and divide by 2, that equals the X value of my midpoint. So if I add up these two X values, 12 plus X, and divide by 2, it should equal the X value of my midpoint. So add up these two, divide by 2, so average them. It has to equal this value here in the middle. And then you can just do algebra. You could solve for X. So multiply 2 to both sides, and then subtract 12. You'll still get the same answer that I got before. And again, it could work with the Y's. You would say that if I added up -10 and -2, if I added up -10 and Y, it would have to equal the Y value of -2. Remember that you're taking the average of that, so you're dividing by 2. I'd multiply both sides, add 10 to both sides, I get Y equals 6. So remember that this was the same answer I got when I did it the other way. So if you like the more mathy way of doing it, you can set up your equation. I like to think of it as just kind of like equal distances apart. And I said, oh, I went from 12 to 4. I went down 8, so I have to subtract 8 here. And from -10 to -2, I added 8, so I have to add 8 here. That's how I do it, but either way would work. All right, next, distance formula. Again, we did a investigation on distance formula, so if you haven't done it, please make sure you do the investigation first. So distance formula is, again, just a variation of the midpoint formula and the Pythagorean theorem. All right, so an example might say, find the distance between -1,6 and 4,13. All right, so how do we do this? We plug it into our equation. So the distance between these 2 points what you do is you take, we'll call this x1, y1, x2, y2. You take the difference between your x values, so x2 minus x1, and you square it. So 4 minus -1 squared, plus, and then take the difference between your y values, so 13 minus 6, and square it. And then you're going to take the square root of that whole thing. So I would get 4 minus -1 is 5. 5 squared is 25. 13 minus 6 is 7, and 7 squared is 49. And so I get root 74. If this radical could be reduced, I want you to reduce it. In this case, it's not. So we will leave it at root 74. I do not want you to write it as a decimal, at least for when I have you write down answers. If Big Ideas asks you to write it as a decimal, that's fine, but I don't need you to take that extra step. All right, that's it for lesson 1.3. If you have any questions, record them, write them down, whatever you got to do. Come see me, obviously ask them in class or email me privately, and I will do my best to explain. All right, bye for now.